Alright, so my video is on balancing chemical equations, and to explain why we balance chemical equations is because of the law of conservation of mass, which is that energy cannot be destroyed or created, only transferred. So you have to have the same amount of elements that you had on the product side as you have on the reactant side when you end your equation. So now we're going to go through a problem of how to do a generic balancing equation. So we started with H2O, which makes H2 plus O2. So on each side we have two elements. We have H and we have O. So on the reactant side, we start off with two H's and one O. And on the product side, we have two H's and two O's. Now we want to make the H's and the O's exactly the same number on each side. So to get from one O to two O's, we're going to put a 2 in front of the H2O, which will give us two more H's and one more O. But now on the reactant side we have four H's, and on the product side we have two. So we need to add two more to the H2, which would give us two more H's. So now our balanced equation would be 2H2O yields 2H2 plus O2. Alright, so now we're going to do some sample problems that are a little bit harder than the last one. So our first one, we have Fe plus Cl2 yields FeCl3. So on the reactant side, we have one Fe and two Cl's. And on the product side, we have one Fe and three Cl's. So we want to go from two Cl's to three Cl's. But you can't really do that, so we're going to do a common multiple, which would be 6. So we're going to multiply the Cl2 by 3, which would give us 4 more Cl's. So you'd have 6. And we're going to multiply the FeCl3 by 2, which would give us 3 more Cl's, which would give us 6. But that would also give us another Fe. So now we have to make the Fe's balanced, so we have to put another Fe on this side. So our balanced equation would read 2Fe plus 3Cl2 yields 2FeCl3. For our next example problem, we have CH4 plus O2 yields CO2 plus H2O. So on this side, we have one C, 4 H's, and 2 O's. And on the product side, we have one C, we have 2 plus 1 O's, so we have 3 O's, and we have 2 H's. So we're going to balance our H's first. So we have 4 on this side and we have 2 on this side. So we want to add 2 more. So we're going to put a 2 in front of the H2O, which would give us 2 more H's, which would also give us 1 more O. So now we have 4 O's on this side and 2 O's on this side. So we're going to multiply the O2 by 2. So now we have 4 O's. So now we have the same number of C's, H's, and O's, and our balanced equation reads CH4 plus 2O2 yields CO2 plus 2H2O. Okay, for our last balancing problem, we're going to do a little bit harder one. So we have KMnO4 plus HCl yields KCl plus MnCl plus H2O plus Cl2. So on our reactant side, we have 1K, 1 Mn, 4 O's, 1 H, and 1 Cl. And on our product side, we have 1K, 1 Mn, 1, 2, 3, 4 Cl's, 2 H's, and 1 O. So first we're going to balance our O's. We have 4 O's on this side and 1 O on this side. So we're going to put a 4 in front of the H2O, which would give us 3 more O's, which would also give us 8 H's. So we're going to add 6 more H's. So now we have 8 H's on this side and 1 H on this side. So we're going to put an 8 in front of our HCl, which would give us 8 H's, which would also give us 8 Cl's. So we have 8 Cl's on this side, and we only have 4 Cl's on this side. So we're going to put a 2 in front of our Cl2, which would give us 4 more Cl's. So now we have 1 K, 1 Mn, 4 O's, 8 H's, and 8 Cl's. And our balance equation is KMnO4 plus 8 HCl yields KCl plus MnCl plus 4 H2O plus 2 Cl2. So now we're going to use our balance equation to do a limiting reactant problem. So we're given C6H12O6 plus 6 H2O yields 6 CO2 plus 6 H2O. And we're given 25 grams of C6H12O6 and 40 grams of O2. So our first step is convert the grams to moles. So we're going to take our 25 grams of C6H12O6 and we're going to divide that by the mass on the periodic table, which is 180.06, which equals 1 mole. And when you divide that, you get 0.1388 moles of C6H12O6. So we're going to do the same thing for O2. We're given 40 grams of O2. And we're going to divide that by the mass on the periodic table, which is 32 grams for every 1 mole. And when you divide that, you get 1.25 moles of O2. So now we're going to take our moles and we're going to convert them to one of the elements. I'm going to pick CO2 on the product side using our numbers in front of the elements, using our balanced equation. So we're going to take 0.1388 moles of C6H12O6, and the number in front of that is a 1, and then we're going to convert that to CO2, which is a 6. So when you divide that, you get 0.833 moles of CO2. So we're going to do the same thing with O2. So we have our 1.25 moles of O2, which is a 6 in the balanced equation, and CO2 is also a 6. So when we divide that, we get 1.25 moles of CO2. So to determine our limiting reactant, we look at the moles of product made, and whichever one has the least moles of product that is made, that is your limiting reactant. So in this case, our limiting reactant would be C6H12O6 because it made the least amount of product.